Welcome to this video series, produced by CEP Forensic, which will introduce you to the science of forensic engineering. In this first video, we will talk about explosions in order to better understand this phenomenon and the parameters that govern it. First, we'll define the main terms and then the conditions that must be met for an explosion to occur. We will talk about different types of gaseous fuels and the importance of their concentration in the air. The main sources of ignition will be discussed, and we will end with the reaction rates, which are, more often than not, proportional to the observed damage. Deflagration and detonation are two modes of explosive combustion that release energy. If the combustion front is propagating at subsonic velocity, it's a deflagration. If the combustion front is propagating at supersonic velocity, it's a detonation. Explosion is a more generic term meaning the sudden conversion of potential energy into kinetic energy with the production of pressurized gas, which displaces or shatters nearby materials. Although an explosion is often accompanied by a loud noise, it is not an essential element in defining an explosion. The first criterion is the generation and sudden violent escape of gas. Combustible explosions occur in the presence of an optimal mixture of combustible gas and ambient air. If the mixture is too rich or too lean, there will be no explosion or ignition. For example, for natural gas, the flammable limit as a percentage of volume in air is between 4.5% and 14%. Hydrogen, on the other hand, has a very wide range between 4% and 75%. It is therefore more dangerous than natural gas. In addition, each fuel mixture requires a minimum ignition energy of less than 1 millijoule, which is a very small amount of energy. In an explosion, the fuel is in a gaseous form or in the form of a dust so fine that the solid particles behave almost like a gas. All combustible dusts are capable of causing an explosion as soon as the particle diameter is less than 500 microns. The food, wood, paper, and metal industries have processes resulting in the residual production of fine dust. These include starch, flour, cotton, sawdust, and plastics. These dusts are flammable and present a high risk of deflagration. And yes, even the dust produced by certain metals, such as aluminum and magnesium, can cause explosions. Finally, smoke, which contains fine particles and some unburned gases, or a gas such as carbon monoxide, has the potential to explode. Gases and dusts, if in the flammable range, can be ignited by a variety of heat sources, the main ones being open flames, hot surfaces such as a motor or light bulb, mechanical heat, unlubricated bearings, static electricity, and arcing associated with electrical equipment. The damage caused by the blast of an explosion depends on the energy released, but above all, on the speed of the pressure rise. Relatively slow rises in pressure will produce effects such as displacement or swelling. Windows will often act as vents, reducing overall damage caused by the effects of the explosion. When the structure containing the pressure surge ruptures, it often breaks into fragments that can be projected over great distances. The gases from the explosion can reach high temperatures that can ignite fuels of low thermal inertia. In some cases, the fire is the primary event and the explosion is the consequence. The presence of a crater is typical of a concentrated explosion, usually involving detonation. The investigator must know the explosive limits of different products and the possible sources of ignition in a given environment in order to establish the probable cause of the explosion and determine if it was accidental, if safety standards and rules were broken, or if it was an intentional act. If you are interested in fires and explosions, contact our experts or read our articles on the subject.